Let's hear about pushing the boundaries of HCS through on-graph content. So this workshop is going to introduce you to the Hedera Consensus Service standards that to facilitate file data management, recursion, and even things like dynamic NFTs. So please join me in welcoming to the stage community builder and founder of KiloScribe, Michael Kantor.
Hi everyone, how are you doing today? Mic check, mic check. You guys can hear me okay? Give me a thumbs up. Sweet, sweet. Today, we're going to talk about pushing the boundaries of HCS through on-graph content. Can I get a whoop whoop? There we go. Let's go. So for those who don't know me, I'm Michael Kantor. I am the president of Hashgraph Online, and I'm also the founder of KiloScribe. You might have heard about us because we created Hashinals, and as of today, we've generated 11.5 million transactions on Hedera mainnet for storage, and we've also played a part in a number of other standards. So we're going to do a bit of a speed run through some of the standards that we've built over the past year. It'll be a little bit technical, but I will try to make it easy to digest. But you're open to record and take notes as we go through the session. So jumping in, we're going to cover what Hashgraph Online is. Then we're going to jump into HCS1, which is the storage standard for Hedera, using the Hedera Consensus Service. We'll go a little bit into the weeds of recursion and recursive assets, things like link pages. And then at the end, we're going to leave you with a teaser for Smart Hashinals, which is a new standard and also asset class coming to Hedera soon. All right, so let's kick it off. You've probably heard of Hashgraph Online through passing. We are a consortium of 9 leading retail-facing organizations on Hedera. It's composed of the likes of Hashpack, Builder Labs, Hashgate, Hgraph, Launchbadge, KiloScribe, Centex, and TurtleMoon. It is a structure that is kind of similar actually to how Hedera LLC is governed. So the idea is that we come together and we build these open source standards on the Hedera Consensus Service, and then we also, as part of that, we build open source tooling and applications. Another teaser into this is we recently announced that we're building the first Web3 browser that's totally based on the Hedera Consensus Service, aka Moonscape. So at the end of this, if I encourage everyone to chat with me, I'd love to tell you all about the browser, but for this panel, we're going to go into the weeds of the technical side. So without further ado, what is HCS1? So HCS1 is the de facto standard for storing files on Hedera through the Hedera Consensus Service. The way that it fundamentally works is, imagine you've got this piece of paper, and you cut this piece of paper up into 4 little pieces. This piece of paper might be a JPEG for an NFT. It might be some valuable schema data or something else. And the way that the standard works is after we've broken the paper up into 4 little pieces, we go and put them on an HCS topic. During that process, we also compress it to make it smaller. And on the other end, when you open up your wallet and you want to see what a Hashinal looks like or an inscribed file, we're basically taking those 4 quadrants on that piece of paper and we're reassembling them in real time for you to see. And you might be wondering, like, why are you breaking it up? Why is it 4 different quadrants? That's because the Hedera Consensus Service actually limits us to 1 kilobyte messages. And in order to put these big files, of course, most files are more than 1 kilobyte. Most PFPs are probably around a megabyte. So you do have to break it up into these little chunks. And you've probably seen from our accounts, we'll say the word chunking, because that's what we're doing. We're chunking the files into little pieces, putting on an HCS1 topic, and then you're able to go and put those pieces back together at the end and get a full file. Next, you're probably wondering too, what are the benefits of HCS1? It sounds really cool that we can put files on chain, but why would I want to do that? So number one, when you use HCS1, your files are 100% on graph, and you've probably heard some of the inklings around block nodes too, and that gets me really excited. And what that means is your files are on Hedera, and you don't have an outside dependency. For example, a lot of NFTs will typically use something like IPFS or Arweave or maybe even centralized solutions like Amazon S3. But if you're building decentralized protocols and applications, you might really be interested in having your file actually on the network that you're building on. You know, worst case, if IPFS goes down for some reason, well, then your files are lost. Or what if your S3 bucket gets deleted for some reason? With HCS1, you wouldn't need to worry about that. Additionally, because these files are on Hedera and HCS1 is widely supported in the ecosystem, they can be tokenized and available in major parts of Hedera. So for example, you can access HCS1 files and Hashinals directly in Hashpack. You can buy and sell them in Centex, and you can even view them in explorers like Hashscan. As a standard on the technical side, there's a lot of ways where you can put files on Hedera. We even have a file service, and we didn't use that. We used the Hedera Consensus Service because you can get that really fast storage. Hedera, we know it goes up to 10,000 transactions per second. If you're writing really big files, like for example, the first one of the first Hashinal collections that we launched, it was 3.2 gigabytes of data, gigabytes. And if we used like the file service, it would have been insanely expensive and it would have taken a long time. But because of how the standard is set up, we can inscribe these files, and inscribe is the geeky word we use when it comes to things like HCS1 and Hashinals and ordinals. We can inscribe it in parallel. So you've got a JPEG that has 10,000 kilobytes in it. We can upload all 10,000 kilobytes at the same time on different threads using the Hedera Consensus Service because it's fast and cheap. Additionally, it's very flexible as a service. HCS is widely supported through Marinode APIs and infrastructure. So the standard just works out really well for those reasons. Jumping ahead, this part is a little bit technical, but I'll try to dumb it down a little bit. This is the structure of an HCS1 file. If you were to manually, you want to create a file and put it on Hedera through the HCS1 standard, it essentially is quite similar to a JSON API, if you want to call it that. Every single message that's put onto an HCS1 topic ID, it's just JSON. That's what it is. And we've got these two fields on it. It's extensible for future augmentation. The two fields are this O field here, which you can see on this line coming here, and it's got a number around it. That O field is really important, and we're going to come back to it, but it's essentially the order of how the parallel chunks are combined. Then you've got the C field, which is your content. So I've got this 100 kilobyte file. I break it up into 100 pieces, and I compress it. Each C represents a chunk of that file. So at the end of it, what we're doing is we're basically combining all of those O's and C's, and we're sorting it by the O, and we're decompressing it, and boom, we've got an HCS1 file that loads in your wallet, it's tradable on Centex, and it's available in Explorers. Next, the second and probably the most important thing about any HCS standard that we've built is how we utilize the topic memo. So the topic memo is a really cool thing that Hedera built into most transactions on the network. It is a 100-character field. You could put anything that you want in it. Doesn't mean that you should, and our opinion is that we should standardize it on how we use that memo field. So with HCS1, and obviously you have 100 characters, you're very limited in what you can put in that memo field. So the three most important things for us were a SHA-256 hash, I'll come back to this in a second, that represents your file, the compression algorithm, and we currently support Brotli and ZSTD, as well as the encoding mechanism. So you're probably wondering, what is this hash? What is a SHA-256 hash? I don't know this stuff. Essentially, what it means is you have a 100 kilobyte file, you can, utilizing SHA-256, you can generate a unique hash. And it'll always be the same for that file every single time. So we store that hash on the topic memo, and here's why. When a platform is reassembling all the chunks from this HCS1 file, we need to be sure that it's actually the same file. We need to verify that it's the same file, and that ordinance is actually really important for Hedera as an ecosystem, because you can think about all the use cases where verification can actually be really interesting, aside from other ways that you can put files on a decentralized network. The compression algorithm, and this was also really forward-thinking, the idea is that we're not storing the raw file on the Hedera Consensus Service. We're using compression algorithms like Brotli or ZSTD to make it smaller so that you can put your file on graph for less messages than you would need to. And depending on what kind of file type you're using, you might use a different compression algorithm. If it's a text-based file, like an HTML file or JSON, you'll use Brotli. If it's an image, you'll use ZSTD. And the encoding, right now, we just have base 64 encoding, but in the future, we might add more methods of encoding as well as compression algorithms. The other cool thing about the JSON structure is that HCS1 is extensible. So if we ever want to create a new version of HCS1 or we want to bump it up because it is JSON, we can add new fields to it later on. So we talked a lot about HCS1. We did a little bit of a speed run. Next, we're going to talk about HCS3 recursion. You might have heard about recursion from the ordinals ecosystem, and recursion on Bitcoin, the need for it became because Bitcoin storage is so expensive, right? And if you're creating a generative collection of PFPs, to have to go and inscribe each file manually, like literally to put a gigabyte on Bitcoin, you'll spend $1 million. On Hedera, that'll cost you $200. So they had to come up with a way where instead of having to do that every single time, maybe they could reuse the layers in these PFP collections. They've got the same clothing, eyes, etc. You might have heard of Taproot Wizards. They've got HTML ordinals that do this exact thing. So recursion on Hedera is similar, but on Hedera, everything is so cheap because of the fixed fees and low transaction fees. We don't have to worry as much about the cost. Instead, we can start thinking about recursion as an add-on to start developing a fully on-graph ecosystem. So, for example, at KiloScribe, we created this cool thing called link pages. Link pages are a decentralized alternative to link and bio tools. You've probably heard about Linktree, right? So it's a similar concept, but your link page is 100% on graph. And that's really interesting from the perspective of recursion, because like you see in this library, I've got all of these logos that I've already inscribed in the past. My KiloScribe logo, Hashpack, TurtleMoon, and inside this Hashgraph Online link page, I'm actually reusing them right here. So that's essentially how recursion works, is similar to the JavaScript and NPM ecosystem. We are able to import these reusable assets anywhere we want inside of these HTML files. And that's kind of the basis for the new internet as we build more applications like link pages. How can we start reusing JavaScript libraries, CSS libraries, toolkits, some of which Hedera is creating? We even we inscribed Wallet Connect as one of the SDKs, and you can use that inside of an HTML Hashinal, and you can create games. So as a game developer, you can start reusing libraries without having to pay to inscribe each time. And more importantly, from a Git or version control perspective, this unlocks a lot for developers. So to summarize, what is recursion? Inscribe once, reuse anywhere. So more on the technical side, this is how recursion kind of looks like. So the idea is that inscribed assets would utilize either an HRL, which is HCS : //, or in the future, ORD protocols, ORD : //. That's the syntax that Ordinals utilizes. HCS3 is a standard that's meant to not only enable Hedera with recursion, but also other ecosystems like ordinals, IPFS, Arweave, etc. in the future. And that's the beauty of these standards, is that yes, it's built for the Hedera Consensus Service, but there is no reason that we cannot use these standards in other ecosystems like Bitcoin, or even if you wanted to stretch it, you could make this work inside of a smart contract. So with HCS3, we have this recursion SDK. It runs on every HTML file, and it's looking for essentially that syntax, that HCS syntax. So for example, over here, we have this script, right? And it's got HCS 1, 0, 1, 2, 3, 4, 5, 6. And the SDK realizes, okay, this is some CSS, and we're going to load it into the page. Same thing over here. You've got this ordinal, which is a PNG. It just looks at it, recurses through, loads the data, and renders it in line inside of the HTML. And same thing with the JavaScript. Now, recursion is just a standard. There's a lot of ways you can implement it. We've built a JavaScript SDK that works really well on the client side. But if you wanted to take it a step further, a server can do this exact work to basically render recursion in real time from a front end if you don't want to wait for the client-side script to execute. So if you're a developer in the room and you want to get started with HCS3, we built a easy-to-use npx command. You just run npx create recursion app. Boom, 2 seconds. It'll pop up on your laptop. If you want to try it right now, you're open to it. And it'll start running in your browser. You'll get this cool little application that's actually utilizing WASM to move a little cube across the screen. And that's another thing with recursion, is that you've got that WASM enablement. And you'll see us LARP on about WASM quite a bit in the Hashgraph Online ecosystem. So again, if you're a developer, I do recommend taking a look at Rust and WASM, as that's going to be a huge staple in some of the things that we're building. I'm going to try to go a little bit fast now. See, we're getting close on time. Next, we're going to talk about Smart Hashinals. Smart Hashinals actually won second place in the Hello Future Hackathon, as well as 2 categories. It is a new asset class on Hedera, and essentially it is the on-chain version of if this, then that for NFT selection. So you can see on the example here, I have a dynamic hashinal, and utilizing the standard, you can, let's say it's during the nighttime right now, let's say it's 1 a.m., you'll have this version render, and if it's during the daytime, you'll have this version render, utilizing the standard. We're getting into the weeds of it. So how does HCS7 work? So fundamentally, a client requests an HCS7 topic. Again, it's got its own custom memo, similar to HCS1. And it's able to say, okay, yeah, this is an HCS7 topic. Cool. And then, inside its configuration, we have this setup that says, call this smart contract to get this data, call this smart contract to get this data. So it retrieves this data from the smart contract. That's its input. And then it sees that there is a WASM config. So essentially, you have this WASM file that's also inscribed and stored as HCS1. And the server takes the input that it got from the smart contract, and it says, okay, I see that the price of HBAR is over $1 right now. Let me render this version. Or if it's under $1, let me render this other version. And that's essentially how HCS7 works in a nutshell. We've built a lot of open source tooling around this. We've built a bridge as well as an SDK, and it's currently in testnet today. We're in a draft. We have a draft standard up, so if anyone wants to contribute to that standard, you're more than welcome. Another addition that's coming soon is essentially, right now it's programmatic selection of topic IDs, but in the near future, your WASM config will actually be able to render its own metadata in real time based off the input that it got from the smart contract. So you're wondering, well, this is a really cool standard. What are some of the use cases of HCS7? So for example, holder reactive identity. You can have a DID profile that's utilizing a smart hashinal, and it's pulling smart contract data on your holdings. What's your HBAR balance? How many tokens do you have? And based on that, you get a different badge. So like your badge and your profile will change over time, your identity would change over time based on this data from the smart contract and how the WASM is interpreting it. Composable game assets, if you're making a game or a metaverse or something like that, utilizing HCS 7, you create these really elaborate experiences as you're fighting in the game, you won a battle, you got some experience points, and you leveled up. Through HCS 7, you can reflect those stats immediately in the metadata that the WASM is outputting, all 100% on graph. And also DeFi topic selection for use cases like AMMs and things like that. You can actually, when you issue your NFT tokens that represent your LP position, you can utilize the HCS 7 standard to show what your position is in real time through the metadata. So that was a speed run into HCS 1, 3, and 7. I would say for anyone in this room, again, we are launching a browser for the new internet called Moonscape. So if you're interested in learning more about that, please reach out to me. If anything else, go to KiloScribe.com and HashgraphOnline.com and check out some of the cool stuff that we've got. At KiloScribe, we've made it as easy as using Dropbox to go and inscribe your first Hashinal. I've got my no-code shirt on right now. So it is really easy. I recommend everyone in this room give it a shot. Or if anything else, create a link page. You won't have to run any code, and it'll cost you less than $1 to get started.